Welcome, network architects. Today we are exploring how to configure multi-tenancy in NVIDIA Spectrum networking. We will focus on utilizing Border Gateway Protocol Ethernet VPN, or BGP EVPN, to strictly isolate tenant workloads. Let's get started. Let's begin by defining BGP EVPN. EVPN is the control plane for modern VXLAN overlays. In the past, VXLAN relied on flood and learn mechanisms, which flooded broadcast traffic everywhere. That is terribly inefficient and scales poorly. By leveraging multi-protocol BGP, EVPN transforms this process. It explicitly exchanges MAC and IP reachability information between switches. Why is this critical for AI data centers? Because in a multi-tenant environment, you need absolute isolation and massive scale without broadcasting noise across your expensive AI fabrics. In our deep dive, note that EVPN achieves this using specific route types. Type 2 routes handle individual MAC and IP addresses, while Type 5 routes handle entire IP prefixes. This allows NVIDIA Spectrum switches to build highly efficient, targeted forwarding tables. Looking at this diagram, you can see the separation of the control plane and data plane. The solid lines represent the BGP EVPN control plane communicating through the spine to distribute MAC and IP routes. The dotted line represents the actual VXLAN data plane tunnel. EVPN tells the switches exactly where the endpoints are, allowing the VXLAN tunnel to deliver the data directly without unnecessary flooding. On slide 2, we look at the actual isolation engine, virtual routing and forwarding, or VRF. What is a VRF? Just as a VLAN isolates layer 2 broadcast domains, a VRF isolates layer 3 routing tables. The basics are simple. Every tenant is assigned their own VRF. Why is this mandatory? Because in a cloud environment, tenant A and tenant B might both decide to use the 10.0.0.0/8 IP subnet. Without VRFs, this causes a catastrophic IP conflict. How do we move this isolated traffic across the network? We map each VRF to a layer 3 VNI. For our deep dive, you must understand route distinguishers and route targets. Because overlapping IPs look identical, BGP appends a route distinguisher to make them mathematically unique. Route targets then dictate which switches are allowed to import or export these specific tenant routes, enforcing strict security boundaries. This visual clearly demonstrates the power of VRFs. Notice that both tenant red and tenant blue are using the exact same IP address, 10.1.1.10. However, because they enter the switch on interfaces assigned to different VRFs, they are completely isolated. Tenant red's traffic is mapped to L3 VNI 4001, and tenant blue's is mapped to L3 VNI 4002 before entering the shared spectrum fabric. Slide 3 covers a critical design choice: symmetric integrated routing and bridging, or symmetric IRB. What does this mean? It means the routing and bridging decisions happen symmetrically at both the ingress leaf and the egress leaf. Why is this important? Because the alternative, asymmetric routing, requires every switch in your data center to maintain configurations for every single VLAN, even if that switch doesn't have those hosts attached. That exhausts switch memory quickly. How symmetric IRB works is elegant. The ingress leaf takes the packet from the source VLAN and routes it immediately into the tenant's global L3 VNI. The packet crosses the fabric, and the egress leaf routes it out of the L3 VNI into the destination VLAN. Our deep dive here is about scale. By using symmetric IRB, Spectrum switches only store MAC and ARP entries for local hosts, drastically conserving TCM and allowing your multi-tenant AI cloud to scale infinitely. Follow the packet flow in the sequence diagram to see symmetric IRB in action. The source host sends a packet on VLAN 10. The ingress leaf routes it into the shared L3 VNI and encapsulates it in VXLAN. It travels the fabric. Finally, the egress leaf decapsulates it, routes it out of the L3 VNI, and delivers it to VLAN 20. Routing happens twice, symmetrically. Now we move to the actual configuration on slide 4. We use NVIDIA, the NVIDIA User Experience CLI. Before EVPN can function, you must build the underlying BGP network. How do we do this? First, we assign an autonomous system number. Looking at the sample code, we type NVSet router BGP autonomous system 65101. Next, we must tell BGP to exchange EVPN routes, not just standard IP routes. We do this by activating the L2 VPN EVPN address family on the uplink interfaces, as seen in the second snippet. The deep dive here is an incredible feature of Cumulus Linux, BGP unnumbered. Normally, setting up BGP requires carving out hundreds of small/30 IPv4 subnets for every point-to-point link. BGP Unnumbered automatically discovers peers and establishes sessions using IPv6 link local addresses that are hardware generated. This saves massive amounts of configuration time and prevents IP exhaustion. This flow shows the logical configuration hierarchy. From the NVIDIA CLI, we push settings into the BGP process, powered by FR routing under the hood. BGP establishes the underlay network using unnumbered peering. Simultaneously, we activate the EVPN address family, layering the multi-tenant control plane perfectly on top of the physical underlay. Slide 5 tackles the tenant-specific configuration. Now that the underlay is up, we must attach our tenants to the overlay. First, we enable EVPN globally with NVSet EVPT enable on. Next, we map the tenant's VRF to their unique VXLAN identifier. Using our sample code, NVSet VRF red EVPT NI 4001 perfectly links the logical routing table to the transport tunnel. Finally, we must tell the switch to actually share the tenant's routes. This is the route export command shown in snippet 3. As our deep dive explains, this is the bridge between the VRF and the EVPN control plane. It takes the local IP addresses residing inside VRF red and injects them into BGP as EVPN type 5 routes. Without this command, the isolated routes would never leave the local switch, and remote tenant servers would be unreachable. Observe the route export process. The local tenant route populates the VRF red routing table. Because we applied the route export command, the switch converts this into a BGP EVPN type 5 route. It tags it with VNI 4001 and advertises it up to the spine switches, propagating the tenant's reachability across the entire data center. Let's put this into a highly critical real-time use case. Imagine you operate a cloud hosting environment on an NVIDIA DGX SuperPod. You have two competing AI startups as clients. Tenant A is training a highly confidential LLM. Tenant B is running a public inference API. For their internal orchestration, both tenants mandate using the 192.168.10.0/24 IP subnet. How do you allow this without data leakage? You deploy a BGP EVPN symmetric routing architecture. You assign tenant A to VRF alpha with L3 VNI 5001 and tenant B to VRF beta with L3 VNI 5002. The outcome is total security. The Spectrum switch ASIC enforces this isolation at the hardware level. Tenant A's packets are hermetically sealed inside VNI 5001. They can share the exact same spine switches and fiber optic cables as tenant B, but their data planes will never intersect. This diagram visualizes the multi-tenant AI cloud. Both tenant A and tenant B use the exact same IP address. They both plug into the exact same physical leaf switch. But because they are bound to different VRFs, the switch encapsulates their traffic into separate VXLAN tunnels, 5001 and 5002. The spine switch transports them securely as completely independent data streams. We have reached our final slide. Configuration is only half the battle. Validation is the rest. You must verify that your BGP EVPN fabric is healthy and that tenants are properly isolated. You can check the operational state of a specific VRF using nvshow VRF red EVPN BGP info operational. To see a global view of all advertised VNIs and gateways, you can drop into the Linux shell and run net show BGP EVPN. Because EVPN can be complex, I strongly advise against testing in production. Build a digital twin of your network using NVIDIA Air. It allows you to simulate Cumulus Linux, test your VRF configurations, and ensure isolation works perfectly before touching a physical switch. Thank you for joining this session. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final flowchart outlines your deployment methodology. You write your NVIDIA EVPN configurations, then immediately simulate them in NVIDIA Air. Once your digital twin passes testing, you deploy the code to your physical Spectrum switches. Finally, you continuously validate the state using netq and nvshow commands, resulting in a secure, production-ready AI cloud.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. We have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.